In this video, we're going to solve a few more compound interest problems. Let's review looking at our formulas. We've got future value is FV, present value is PV, T is time in years, R is our annual interest rate, M is the number of times per year interest is compounded, and MT, our exponent here and here, is the number of compounding periods total. So if we're compounding every month for a period of 3 years, that MT is going to be 36. Let's look at a few different ways the interest rate and compounding style can be presented in words. So if I look at this first example, it says 4% per year compounded monthly. This is exactly how we've seen it in previous example. And so in this case, it's compounded monthly, so M is going to be 12, and it's 4% per year, so our R is going to be 0.04, and R divided by M is 0.04 divided by 12. In this next example, they say 3% compounded daily. So this 3%, even though they don't say it's per year, it doesn't say it's not per year, and so we can assume that it is per year. So the 3% is the value of my R, and it's compounded daily, so we're going to have 365 days. Our R divided by M is going to be 0.03 divided by 365. Now in this next one, it says 2% every 6 months. In this situation, they're telling us the compounding rate per period. Our interest is being compounded every 6 months. There's 2 6-month periods in each year, so our M is going to be 2. And they don't tell us the value of our R, they tell us the value of our R divided by M. So R divided by M is 0.02. Now if we wanted to calculate R, we usually don't need to, but if we wanted to calculate R, remember R divided by M times M. If I do the algebra on that, those M's cancel and I get just R. So if I wanted to find the actual R, all I needed to do is take the 2 times 0.02. But again, we probably won't need to use this information, even though that's correct. In the next example, again, they're telling us the compounding rate per period instead of compounding per year. So they say 1% per month. So that tells us if it's each month is compounding, it's going to be compounding 12 times per year, and our M is 12. And our R divided by M, our rate of compounding per period, is going to be 0.01. And again, we probably don't need this value, so I'm just going to leave it blank. But if I wanted to find it, all I would need to do is take this 0.01 and multiply by the 12. Looking at the next one, we're told 0.5% per quarter. So we're compounding quarterly, so our M is going to be 4. They don't give us the annual rate, they give us the rate per compounding period, and so my R divided by M is going to be 0.005. Now let's talk about how I got that. If I have 0.5%, remember when I go to convert a percentage to the decimal value, what I need to do is I need to take that number and divide by 100, or the other way you can think of it is taking the 0.5 and we need to move the decimal place 2 spots to the left. That's like dividing by 100, so 2 spots to the left, and so this is where my decimal point is, and that's how I got that number. Last example, we have 2.5% every 3 months. Now if we think about how many periods of 3 months we have in 1 year, there are 4 of them, because 3 times 4 gives me 12. So This is just another way of saying compounded quarterly. So if per quarter is the same as every 3 months. Again, I'm given my rate per compounding period, so I don't need to actually calculate what my R is because I'm going to use my R divided by M in my formula. So my R divided by M is going to be 0.025. In this example, they tell us housing prices have been rising by 0.5% each quarter. A new home in your desired neighborhood currently averages $250,000. Assuming that the growth rate remains consistent, what is the price in 2 years? Round to the nearest $100. As usual, figure out what our given information is and what our goal is. So looking up here, they tell us that our housing prices have been rising by 0.5% each quarter. So since it's quarters, we know our M is going to be 4, and they tell us it's 0.5% each quarter. So this is not the annual interest rate. This is the value of our R divided by M. So R divided by M is 0.005. We know that a new house in our neighborhood averages $250,000. So that's what it's currently averaging. That is our present value. We're looking for what's going on in 2 years. So we know that our time is 2 years, and my goal is to find what our price is in 2 years. So my goal is that future value. Our formula for compound interest, which we've used a bunch of times, says future value is present value times 1 plus R divided by M to the MT. Let's plug in what we know. So we know our present value is $250,000. So we're going to have future value is $250,000 times 1 plus. Okay, now the R divided by M is this value here. So we're going to put 0.005 here. Now it's tempting to want to divide this by 4, but it's already been divided by 4, so I don't need to do that. My M is 4, it's going to go up in the exponent here, times 2 years. Using our calculator to calculate this quantity here, I end up with $260,176.76 about. Now, they did tell us to round this to the nearest $100. So I'm going to look at my value here, and I'm going to find the hundreds place. So this is the ones, this is the tens, this is the hundreds place. So this is where I want to round. Looking at the digit just to the right, that's this 7 here, that's 5 or bigger, so I know that I'm going to round up. So my answer is $260,200. So we would expect the value to be about $260,200. We're going to continue on with this question, but we're going to ask a slightly different question. So again, we have a house that's $250,000 right now, and housing prices have been rising by 0.5% each quarter. Assuming that this growth rate has remained consistent, which is quite unlikely, but let's go ahead and assume that, what was the price of that house 10 years ago? So in terms of a timeline, right now, we have a price of $250,000, and we discovered in 2 years the price is going to be about $260,200. I want to know, what was it 10 years ago? So we're going to change our perspective a little bit. This was our present value and this was our future value when we did that problem just a second ago. That was this problem, this last problem. What we're going to do now is we're going to turn things around. Now we're going to go over here and look at what's going on in this direction. So this is going to be my future value, and this is going to be my present value. So again, we're changing perspective, and now we're thinking of our future value is that 250,000. My M is the same as it was before, it's 4. My R divided by M is 0.005, and my time this time is 10 years. My goal is to find that value 10 years ago, which would be the present value. We're going to use our same formula, except for we're going to use the version that's solved for present value. Substituting in our values, we have present value is 250,000, 1 plus 0.005 to the negative 10 times 4, so that's going to be negative 40. This gives us approximately $204,784.72. Let's assume that we're supposed to round to the nearest hundred again. So the approximate price of our house 10 years ago was $204,800. Here's another example that has an interesting detail that's slightly different than anything we've seen so far. It says, 3 years ago, you invested some money into a mutual fund on the advice of a friend. Unfortunately, the value of the fund has decreased by 2% every quarter. Yesterday, the investment was worth $1,412.49. How much did you originally invest? So let's, as usual, write down what given information we have and what our goal is. So they're talking about 3 years ago, so we know our time is 3 years. We invested some money on some advice of a friend. Unfortunately, the value has decreased by 2% every quarter. First of all, this is not a situation where they give you the annual rate, they give you the quarterly rate. We know that they give us the R divided by M, and we also know it's quarters, so M is 4. Now, the thing that's really different about this one is they're telling us it's decreasing by 2%. All the other problems that we've done so far, our investment or our account is growing at a certain rate. This is the only one we've done so far where we have an investment that's falling in value. So if it's decreasing by 2% every quarter, then we know our R divided by M is negative 0.02. And we have that negative because they tell us that it is decreasing. We also know that the investment was worth $1,412.49 yesterday. So we'll say that that is our future value. So our future value is $1,412.49. Our question that we're asked, how much did you originally invest? That tells us our goal is how much we originally invested, which was our present value. So we're going to use the same formula that we always use, except for we're going to use the version that's solved for present value. Plugging in our known quantities, future value is $1,412.49. We're going to have 1 minus 0.02. Notice here, I don't need to divide by that M because I've already done it with my R divided by M. And then my M is 4 and my T is 3. I'm going to input this into my calculator, and when I do, I end up with a value of $1,799.999,869 is what my calculator says. So we can assume that we originally invested $1,800, because if we round this, it'll round up to $1,800. Now in this last example, we're told that Ricardo invested $3,000 into an account that earned 6% compounded monthly. predict how long it will take for the account to double in value and round to the nearest 0.1 years. So let's write down our given information and our goal. We know he's invested $3,000. That's our present value. We know the account earns 6% compounded monthly. Now this, it says compounded monthly. It doesn't say compounded or 6% per month. So we know that our R is 0.06. That 6% is our annual rate, and our M is 12 because we're talking about monthly. And it says predict how long it will take our account to double in value. So double in value. So if we start out with $3,000 and it doubles in value, that means our future value is going to be $6,000. And my goal is to predict how long. So we want to know how long or how many years our time it'll take us. Let's plug in the values that we know and see if we can find a way to solve this. I used my regular compound interest formula and I plugged my 6,000 in for my future value, my 3,000 in for my present value, my R divided by M, and my MT. Now, the thing that's unusual about this is the variable that we're trying to solve for is that t that is inside our exponent. In the class that I'm making this video for, we actually don't have the algebraic technique to solve for this. Those of you who have seen a lot of algebra might remember that in order to solve an equation with the variable in the exponent, you need to use logarithms. So we can't solve this algebraically, but what we're going to do is solve this using our graphing calculator.
So to recap, we need to solve the equation 6,000 equals 3,000 times 1 plus 0.06 divided by 12 to the 12x. Notice that I've changed the variable t to the variable x because I'm using the calculator, and in order to use the calculator's graphing screen, I need to have the variable x. So in order to do this, I'm going to graph my function. y1 is 6,000. So what I'm doing is I'm taking the left-hand side of this equation, and that's going to be my y1. So I'm going to have 6,000, and then for my y2 is going to be the right-hand side of my equation. So we're going to have 3,000 times 1 plus 0.06 divided by 12 to the, and I have the 12x is in parentheses. Now if I had the old or the new style of programming where the exponent actually shows up in the exponent, I wouldn't need to use those parentheses. Okay, so now we need to graph, but before I actually press graph, if I press graph, I'm probably not going to see anything. So you can see it's trying to graph, it's working, but we're not seeing anything. And the reason why that is because our window is not set to accommodate these equations. So I'm going to press window. So remember, my x value is my years. So I'm going to guess it's going to take somewhere between 0 and say 20 years to double. In my x scale, this is how often I have tick marks on my x-axis, so that's equals 1, that's fine. And my y-min, my minimum value, I'm going to put as 0, and I want to see above 6,000, so let's go up to 8,000. And my y-scale, if I have y-scale of 1, then it's going to be one solid tick mark on that y-axis, so let's do a y-scale of 1,000. So I have my window all set. Now I'm going to press graph. There's my 6,000 mark, and here is my the value of my investment. See how it looks like a curve and it's going up? This is the spot that we're looking for right here, where my two curves intersect. So to find that intersection, we can use the calculator's intersection feature, and we do that by going second, trace, and then I choose the fifth option here, intersect. Press enter, and then it asks me a series of questions. So first curve, so I'm on my spider right there is on one of my curves. I'm just going to press enter. Asked me for the second curve. Notice my spider moved down to my other curve. So I can just press enter again. If I needed to toggle between my equations, I can just press up arrow and then that'll move between my equations. So once I'm on the equation I want, I'm going to press enter. Then it asks me for a guess. So I'm going to go over here and I'm going to press enter. It looks like our intersection point occurs at x equals about 11.6. So we're going to say x is approximately equal, actually we're going to say t is approximately equal because we're talking about time, and this is 11.6, and then this is years. It takes about 11.6 years for Ricardo's investment to double.